Yeah. Good evening, everyone. Let's start the today's session. Our today's session is all about talking about templates. See, we need to understand what is the need for that particular concept before trying to learn that particular one. Let us see the function overloading once. See, we know the advantages of function overloading. The advantages of function overloading are same name but multiple forms. That is the main thing in polymorphism. We can use the same name but in different ways. We can use the same name for multiple purposes. We so this is a simple example to illustrate the function overloading. Here, the function sum, function name, same name, sum is used for integer addition, integer addition. And we can use the same thing for double addition as well. I am trying to use the same for double addition. Same function name, but the entire arguments are different, and I have written a new function definition also. New function definition is also written. New function definition is also written for the same. New function definition is also written for the same. And if I wanted to do the same thing for one integer and one double, again I need to define the new function. A new function definition is still necessary. A new function definition is still necessary. This is one of the drawbacks of the function overloading. The drawbacks of the function overloading are lines of code are not getting reduced. Only the common thing is function name, which indefinitely it will be using for name stack. Name stack advantage. We already know what is name stack and how it is advantageous while using function overloading. We have all discussed all those things. We cannot pass the data type as a parameter, so that we don't need to write the same code for different data types. The advantage of using templates is this: we can pass the data type as a parameter. We can pass the data type as a parameter. So need for the template. For example, let us take this particular consider this example. A software company may need sort different data types. Rather than writing and maintaining the multiple codes, we can write one sort and pass data type as a parameter. See, we are usually in functions, we do have only two things. We do have call by value, call by reference. Call by value, call by reference. So this will pass the values and this will pass the address. This we are all aware of. This we are well aware of. But what we are proposing here is we want to pass the data type as an argument. Not directly. I don't want to mention. I don't want to mention. I wanted to pass the data type as a header or argument, as something like that. I wanted to. I will not pass even data type, but at the receiver end, I will be considering it as a data type. I will be taking the data type along with the value. We will receive both data type as well as data at the function definition. We'll receive both data type as well as function data at the function definition. That's the meaning of this. So that's why we need template for this. Templates are expanded at compile time. So we do need to create a small template. So how do you create those small templates? This is a simple examples that we have discussed for function overloading, and I'm trying to execute the same. And we've got three outputs. If you people are able to observe in the output section of this particular online compilation thing, we're able to see three different outputs, right? We're able to see three different outputs. So anybody has any doubt regarding how this is getting executed, this function overloading? I hope not. So let's move to the template. How do you create a template function? A template function or generic function, both are same. See, I am trying to create something which is generic to everything. It is trying to accept anything which anybody is allowed to enter. See, let us say a restaurant. See, one small age kid is allowed to enter into a restaurant. One teenager is also allowed into a restaurant. One senior citizen is also allowed to enter into a restaurant. See, that's why we do have some things like in YouTube. There is a section called YouTube Kids. In even Prime also there is kids section was there. In Netflix it doesn't have. So few things were there. So like you wanted to create something which can accept anything generic. So I wanted to write something. I wanted to write some function which is in type of generic. That's what I'm calling it as template. Both are same, template function or generic function. Function template or generic function, we'll call it as like that. So the same thing was what we need is to avoid, to reduce LOC and to avoid confusion, we need template. We need template, function template, function template, function template, or generic function. Function template or generic function. This is what we wanted to create. So the simple generic function for the same thing will be seeing like this. See, here I am trying to create some template. So I wanted to write the syntax for template function. Syntax to create a template. This is how you'll try to create a template. So this is, and we do need to have two keywords. We do need to have two keywords by using keywords template and type name. Type name and template are the two keywords which will allow us to uh, create some template. It will allow us to create some template. All right. So this is how we do it with the help of template and in the Angular braces, which is nothing but mentioning the type name. Type name. So we'll use the keyword type name to create a generic template. To create a generic template, and we'll use the new data type or new template data type, and we'll try to access these things. And I'm trying to return the same thing as well. So that's why we are returning. The function definition will not get changed. Return type, function name, arguments, body of the function. It will remain the same. So this is how we try to create a simple template by using template and type name. Instead of type name, we can use the word class also. Both are same. Instead of this, we can use both. Both are same. Type name or class. Both are interchangeable. Class and template type name or class. And this is also one of the most important interview bit. What is the difference between type name and class in templates in C++? The answer is both words are interchangeable. Both words are same, which is very approximately equal. See, we know what is meant by class. The same keyword class can be used here at the time of creating function templates also. And what are the inner things that we need to understand regarding the templates? Templates are expanded at the compile time. See, even though when we are writing like this, the template, it will get expanded by the compiler at the compile time like this. All these things will be done by the compiler based on what kind of function calls you are giving. Based on this, the compiler will expand the data type. the compiler will expand the function templates. That's the beauty of this. See, when and there is a hidden thing also, lines of code was reduced, readability has been increased because of using the functions, and this doesn't affect the business execution means we try to develop some software and we'll deliver to the client, and client will be using our software, right? And this template will not affect the client's execution because we are compiling it, we'll be creating some executable format software to him, and we'll be delivering the software. See, which will be having less size also because we have reduced the size of the code. It will even take the less size also when we are trying to giving the executable version of the software to the client as well. So these are the different benefits of the function templates. And in templates, we can create two kinds of templates. One is function template and class template. We will see all the different kinds of function templates that we can create, and later we will see different kinds of class templates also, which can be created. How they will working, all those things we'll be seeing now. We have seen from the first in the beginning. We have seen the uh, what is this function overloading, not function overloading, I'm sorry. Yeah, function overloading we have seen, and now we have seen how to create a simple template function. So template, by using the template function and type name, you can either use class also, anything is fine, anything is fine, anything is fine. So I'm trying to tell the return type. Yes, the return type was T, the template what I have created, and it is trying to accept two arguments, A and B, and I'm trying to just return the A plus B. So when you are trying to call this particular function, which is already a template, a generic function, sum is a generic function here. Sum is a generic function. Sum is a generic function here. And to that particular generic function, I have passed two integers, it is working fine. I have passed two floating point values, it is working fine. I have passed, so let us not discuss this here. Yeah. So two floating point values, that is also working fine. Let us see whether it is working fine or not. I've compiled that and it is worked perfectly fine. So 5 plus 6 is 11. 10.5 plus 11.5 is 22. So for both integers and for both floats, it worked absolutely fine. So this is how you try to create a simple template function. A simple template function. I've created that one. Now, so now we'll see how to overload the same thing, how to overload the same function name. See, we have seen function overloading, and now we'll see how to overload a template function. See, template function is nothing but a function which accepts any kind of data types. For that, we are using some keyword called template. Now I wanted to overload these template functions as well. See, what is meant by overloading? Overloading. Guys, are able to understand me? Are able to follow me, guys?
Same function, different functionalities.
Yeah, that's okay. Are you able to understand my pace, or do you want me to change anything in any regard? Everyone able to understand, right?
Yes, sir. Yes, sir.
Yeah. Yes. See, overloading. Overloading is nothing but same name, different functionality. The same thing, same concept applies for everything, whether it is a function or operator or even a template function or even a template function as well. It applies for every other concept. It applies for every other concept. Now we will see how to overload a template function. How to overload a template function. Now we will see How to overload a template function. See, this is how we try to overload a template function. See, now this is a template function which I've created. So you can use either a class name or type name. It's completely independent. I don't mind about it. Okay. See, that's completely up to you. Whether we wanted to use a type name or a class, it is completely up to you according to your programming convenience. You use. But I prefer to use type name all the time. I prefer to use type name all the time because that is which will be more readable for me. See, we know the keyword class is used for creating classes, so I'll be using type name all the time. No difference between this. It is okay. You can use both of them, but I'll try to use type name all the time. See, I've created some function to display. So to display whatever I've got, I will be using this. And we have not specified any data type, which means it accepts any kind of data type. But I have overloading. I'm overloading the same display function for exclusively for integer data types. I wanted to overload the display function exclusively for integer, which means when I call the display function, I'll call the display function, and if it has only the integer type, so the argument must be integer type, then this display function will get called. If I give anything other than an integer, this display function will be overload. This display function will be uh, executed. So that's what it meant. See the example. See how we have trying to use this uh, overloaded template functions. Earlier, I'm trying to call an integer, which means this integer will be called. Later, I'm trying to use some floating point or double function. So then the first display function will be called. Now I am trying to send a character. See, only integer will be used for this function. Rest all the data types will be using this function alone. Exclusive for integers. Exclusive for integers. So we will try to execute this, then you will be able to understand how this is getting worked. See, now if you see this particular example, so for 200 explicit display has been used. So if you can see the output, the exclusively written function for integers has been called. For the next two function calls like 12.40 and character G, you can see displaying template. The template what we have created that has been used. We have overloaded the function display, and the display function is not a regular function, it's a generic function. We are trying to overload the generic function and use it for multiple purposes. When you wanted to overload a function, this is how you try to overload. And now we have seen, now we'll move forward to the next one. Now we'll move forward to the next concept. uh, how to handle two different class names. Sir, we have seen, we have discussed till now, we have discussed a function template which can hold one one data type, with the help of template type name p. We have used it. Now if I am supposed to define a function which accepts two different data types, how do you do that? So that's what we are going to see now. So now we'll be seeing the fourth one. See, template type name T. That's one type that you are expecting. Another type U. Two things that we can be using here. So now I wrote T max TX UI. So which is nothing but I'm expecting two arguments. With this we can say my max function is trying to expect two arguments. That's okay. Now I wanted to write a function. So I have written a function to give the maximum of two numbers. Maximum of two numbers. I have given. That's okay. That's fine. So now max of, so in my coming to the driver function, driver code is nothing but which starts where it starts the execution, where it is starting the execution, where the execution starts, where the execution starts. That's a driver code. So you people know how to write this. I have not used using namespace std or anything is fine. I have not used it, so I am trying to use only std double colon cout. So max 2 comma 3.5, and I'm trying to run this particular one. I have run this one. I am running this, and the maximum of two numbers is 3. That is fine. So now the 2 will be going and sitting in this particular x, and 3.5 will be going and sitting in this particular y. X greater than y? No. I'm using ternary operator for that. So that's why it will return y. And we have written t here. Can anybody guess why the answer is only 3 but not 3.5? We have passed 2 and 3.5. But the output is 3. The maximum of two numbers is 3. Can anybody tell me why we've got only 3 but not 3.5?
Because return type is T, capital T type integer.
Excellent. May I know who is this?
Size.
Not. Okay. Yes, perfectly fine. That is the perfect answer because we are passing two arguments. Not this one, sorry. We are passing two arguments here, 2 comma 3.5, where 2 is an integer and 3.5 is a floating point value. But while returning, we are passing t. What is meant by t here? The first data type. The first data type is integer. So we are trying to return an integer. The value which we are trying to return is 3.5. We are trying to return the integral part only to the main function. So that is the reason we have got 3 here. If you just try to change it as u, we will be getting 3.5. I changed the return type to u and I'm trying to run the function, and now we will see the output 3.5 because of the return type. See, it is just like integer and float. Integer and float, the same thing. But no, not only these two things. You can send anything now. See, I'll try to return. I'll use the same thing, and I'll see. Now I'm trying to vary the things now. 3.5 comma 2. I've changed the 3.5 comma 2. So if you are able to see the difference, I am trying to interchange the arguments. So now, according to me, it should work because I am sending two numbers. At the function definition, I am decoding the data type and value. The data type, the first argument's data type will be coming into t. The second argument's data type will be coming into u. Based on them, I am trying to create two values, x comma y. X comma y. If you see this, so I have written u. U is nothing but the second thing. Here in the second argument, we are sending an integer. So it will be considering as an integer only. You can do both std, cout. We will write just a minute. Now I'll be sending 12.5. I don't know why it is got stuck. A minute. If you see the output, you will be able to understand. See, when I am trying to send, I am trying to use the data type of the second argument. So that's why in the first case, I've got the complete number 3.5. And in the second function call, I've got only 3 because the data type of the second argument is integer. That is the reason for getting the answer as 3. While as in the third function call, I'm using both floats. Both floats. That's why I've got the complete answer 12.5. So this is how we try to handle a function template with two different data types. Now, the actual usage you will be able to see now. Now we have seen some example, like some company needs to sort the data. See, let us say sorting. So a company, two different data types. Just a sec, guys. This is for yourself only, so that you can read it or practice whenever you are free. Yeah. Now, we will see how to sort different, how to sort values of different data types by using a function template. Using a function template. This is what the actual meaning was. See now, the actual usage. The actual usage was, let us say you wanted to you wanted to sort integers. You are supposed to write a function bubble sort with integers. You need to write another bubble sort function for float. You need to write another function definition for bubble sort for characters. You are supposed to calculate, you are supposed to write different logics for different data types. You need to redefine. We need to define every function for every data type. That's the actual beauty of these templates, to reduce the lines of code effectively, and which expands at the time of compilation, not by us, by the compiler, based on the user's choice. Based on the user's choice, it will try to expand. See, let us see how what we have wrote. This is all the bubble sort logic, which no need to introduce. Now, I have created an integer array statically, and I have tried to calculate this number of elements in the particular array. I am trying to calculate the number of elements. Calculate number of elements in the array. Calculate number of elements in the array. Size of A will give the entire size of array. Size of A will give size of array. Size of A of 0 give size of one element. Give the size of one element. So that's how I'm trying to get the number of elements present in the array n, because I wanted to pass the array all the elements and the integer, and which means my template is expecting an array as first arg and integer as second arg. This is my template function. This is the function template that I have created, and my function template is expecting an integer no, not an integer array, an array as the first argument and an integer value as a second argument. See, I need you people to understand here. So till this particular point, we have used directly the templates, either one data type or two different data types we have directly used. But here, I myself, I'm saying that I'm expecting one array. I'm expecting one array and one integer as the second argument. The second argument must be an integer. That's what I'm trying to represent here. So I have created an array here, integer array I have created in this particular example, and I have calculated the number of elements present in the array. That also I have done. And now I'm trying to call this particular function bubbles, and I am passing both array as well as the number of elements also, and which will be coming here. T array. T type. What is the T? Whatever you send. T is the data type that was there here. And what is the T? Whatever the user is sending to this particular function, that is the data type T. That is the data type T. And we are sending here with the help of call by reference. We are using call by reference. We are sending A. A means the base address. Call by reference. See, the entire array went here now. The base address went here. Based on that, I have written my bubble sort logic. See here I have used the different bubble sort logic. You can use the bubble sorting logic what you know. But here you can ask me, sir, you have written directly swap aj comma aj minus 1. Yes, the std the std namespace whatever we are using, it will be having some standard functions like min, max, swap. All these functions will be available with std. You can directly use like this, or you can still use like this std like this. You can use like this std swap. See, swap is present in the namespace std. I'm using the swap to just swap the values between these two addresses. That's all. As simple as that. So now the sorting was done, and after sorting completion, the control comes back to the calling function. The calling function, and I'm trying to print the simple sorting array. This is fine. This is normal function what we write. And now the actual meaning of this. Now I wanted to sort some float point values. I wanted to sort some floating point values. I have created a floating point array dynamic statically with 4 values, and I have calculated the number of elements present in the array as well, and I have passed both of them now. No function definition. I have not redefined another function. I have just used the concept of templates, function templates, simple function templates, and I have created a function template to which accepts an array irrespective of data type. It is expecting an array. This function bubble sort is expecting an array. What type? I don't mind. My logic will work. And the second argument is the number. The number cannot be a floating point value or a character. It should be an integer. That's why I've defined it as an integer. So this is what I have done. And the same logic I have written for float also. I've written the same for the float also. We have called a template function which is passing a floating array and an integer. It's been handled. The function logic has been worked fine, and I am trying to display the sorted order of floating point values also. Let me run this so that you will have a quick understanding how it is getting worked. You can see in the output section the sorted array, where a sorted array of the given values. This is what it is working on. This is how it is getting worked on. And the program was also mentioned over here. It was already kept here. And these are the different programs that you are supposed to do for one week. Let us say whatever the week number that you are following now. These are the programs. These are the 5 programs exclusively. And let me say for like AB for addition, or multiplication. This is 1 week experiment for 1 week that you are supposed to do, and whereas in the second week that we will see now we will see. These are the different topics that we have seen till this particular point. These 5 topics that we have seen: how to illustrate the function overloading, the need for template we have understood, the template function, the simple template function, the syntax we have seen a small example, how to overload this particular template we have seen, bubble sort using generic function we have seen, generic function with 2 different data types, that also we have seen, with type name t comma type name u we have seen, and the maximum we have calculated with that particular part. And now we will see generic class. See, in the beginning itself we have understood, while creating templates we do have 2 different kinds of templates. One is function template or generic function, and the second one class template. Class template and generic class. These 2 things were there. So we have considered all the different possibilities that we have with function template. Now we will see with class template. So how do you create a class? See, regularly, what is the meaning of class to us? Class. So we will be having some class, some name will be there, test, and for that class, some attributes will be there. For that simple class, some attributes will be there, like Let us say I'm doing it in public itself. Public int a comma b, will be saying like this, and we'll be calling some function also, void display. I request everybody to mute yourself, please. So this is a generic class. Now we are telling that okay, your class has, let me take this one, insert table column with the two. Here we have created a class. Here we have created a class with which has two data members of integer type and has a method display. Okay, and has a method display. See, you are, when you are defining the class, while defining the class, we are creating two members and we are specifying the data type as well, which means my class will work only on integers but not floats. Which will not work on floats. See, this is the reason. So you wanted to create something. So why do you need to have? Okay, let us say the same example. We'll be doing it for shape. Then you will understand more. So class shape, class shape. I'm defining the class now. So let us say int a comma b. Int a comma b. Okay. Now I wanted to simply create a class. I mean, like int main, and I wanted to simply create something like, and I will write constructor also for the same shape. I'm writing a non-parameterized constructor here. Everybody knows that one. A is equals to, or we will write a parameterized constructor only. A is equals to int a comma int x. I will write int x comma int y just for readability purpose. Y is equals to, sorry, b is equals to y. Now I am trying to create a simple object s 10 comma 5. This will be working absolutely fine. And let us say there was another function called area. In class shape, there is a function called area. So the values will be going and sitting is 10 comma 5. What if I give 10.5 comma 5.5? We will see. We will see. We will see now. I'm just trying to compile this one. Okay, integer is private, so I'll make it public. Because the constructor needs to be in public, right? The constructor needs to be in public section. Out. It will be there in std. See out in param constructor. Okay, in param constructor, let me run it again. Not this one. Let me see whether it is working well or not. Cout is declared out of scope. Yeah, in parameters constructor, because we have tried to use this. Let me change the value. See the shape. Let us say the shape is rectangle. That shape is rectangle. See, you cannot definitely say the room size will be 10 by 11. The room size may be 10 by 13, 13.5 also. And let us run now. In parameters constructor, there is no error, but definitely it will be receiving only not 13.5. If you wanted to, we'll just try to write one cout statement also in param constructor x comma y comma y. We will write like this. Okay. Now you will see the difference. See, we've got only 10 and 13.5. The 0.5 deprecated. The 0.5 was deprecated. 0.5 in 13.5 is deprecated because in the constructor it is expecting an integer. This is why we need a generic class. This is the need of generic class. Now we will see how to create generic class. Need for a generic class. And shall we put the output screen as well? Let me complete this part. So, the desktop screenshot. So now we will see a simple example how to do the same thing, similar thing, but not in the example of shape and all. I have used with something else. How to create a class template and how to use this particular one. How to use the same class template for one particular parameter. Like we had only integer data types here, right? And how to handle these things alone. First, we will see. So if you try to do this, it can do for two integers, two floats, two doubles, two long doubles, two characters. Anything is possible. Anything is possible. We'll be able to send anything here of same data. So that's what we will see in the beginning. So that's what the first one we will see. Class template with single parameter. I'm so sorry. Just sorry, this one. With one parameter. With one parameter. How do you handle class template with one parameter? See, all this thing is fine. Till this point, no change. I have created a template, or you can use type name here also. Anything is fine. Class or template you can use. And we have created given the template is also okay. And the class name is test, and I have created two data members of T1. Two data members of T1. So which is nothing but my template, my generic type. T1 is the generic type here. I am creating two values for this generic type. And in the public section, I am trying to call the constructor, parameterized constructor, param constructor T1x, T1y. Okay, that's absolutely fine. No doubt about that. That's also done. I'm just trying to assign the values of it. A is equals to x, B is equals to y. That is also okay. Show to just display the values. So A and B, I'm just trying to print the values. This is fine. But how do you create an object for generic template, generic class? See, there is no difference when you try to call a generic function, that is absolutely fine. You can call it the same way. But while creating a object for a template class, there is a slight variation. A very, very, very slight variation was there. And this is that variation. This is that variation. Which data type you are sending, you need to specify. For this is class, this is not just a function. You are mentioning it for a class. Okay. So int t5 comma 6. Instantiation with the float, integer and integer type. Only integer. Only integer. We are sending only integer. So that's why I have written int. That's why we have written int. Let's run this function. You will understand. See, so the execution starts here. So I'm trying to create a test, and this test is not a regular one. It's a generic function. It's a generic class. It's a generic class. So I'm mentioning the type here, or you can simply write like this also: int comma int, or single int is also fine because same data type. There is no difference between both of these things. Sorry, we have only one we have to use. Single thing. Singly we have used it, right? So one template, so only one integer you need to write it. Yeah, this. And now I wanted to do the same thing with two different data types. See, class. See, simple class with generic data type. That's all. Class with generic data types and functions. As simple as that. As simple as that. So now this is done. So now I wanted to uh, template, set two values, display them. Yeah, this is what we have done now. And now we'll see a generic function, a generic class, sorry, generic class with two different data types. Two different data types. Now let us say one int comma float. One int comma float. I will see the program for the same. Multiple parameters. Multiple parameters. See, class T1, class T2. And my data members are T1A, T2B. So same thing. So the same display thing. I'm not changing my business logic here. My thing is was only show. I'm just wanted to display those things. But when you are creating the object, you need to specify like this. Float int. Because you are sending one float value to the constructor when you are calling the object, when you are creating the object, not calling, sorry, when you are trying to instantiate the object with two different data types for a generic class, you need to specify the things. You need to specify the, that's what we are specifying, float and int. And we wanted to create another object test2 with an integer and a character. You are just specifying the character types here. Based on this, the objects will be created. Test1 will be having one float and one int. Test2 will be having one int and one char. But both these objects belong to the class test. That's the beauty. One class, one class, two different objects, but two different, but both objects have different data types. Different data types, not the single data type. That's the actual use of generic class. Once we run the code, you will understand the meaning of this. It will display both the things. Let me close this tab and re-undo this. Yep. I guess you people are able to see the difference here. While sending a float and integer are specified, only this thing will be getting changed. You need to specify what types you are sending. That's all. As simple as that. Integer and character. And we are just displaying the same values by using the show function. So these are the that I wanted to cover in this particular session. Any doubts in these concepts, guys?